Alright, we were so close to finishing that last video before I lost power, so I'll just finish up this last question and we'll start the next one. So the shadow, which is S, not stories, is directly related to the height of the building. And we know that the height of the building, H, is measured in stories, just to be confusing. So we know that the 20 meter long building, so the 20 meter long shadow is cast from a building that is 5 stories high. So if we do that, we can solve for K, and we will get K is equal to 4. Right? And then we get told that the shadow of the building is 32, and knowing that K is 4 times how many stories is the height of our new building? The answer is 8. Okay? So yeah, sorry about that one. I was hoping it would be in the last video, but I guess not. Okay. So remember logarithms, we talk about the logarithm is just 10 raised to what power? So in this situation, 10 to the power of 3, the logarithm is just 3. Now the order of magnitude is, if I were to turn it into scientific notation, so 3.76 times 10 to the power of what? It's this value here, right? So in this case it'd be 1, 2, 3 would be our order of magnitude. A number whose logarithm is 3.56. Okay. This is where I'm going to have to get my CAS up. So give me a moment to do that. But it just means what number is what's this? Now my CAS software doesn't want to load. Try that again. So it's 10 to the power of 3.56 is equal to what? All right, that's essentially the question. And while I get that to load up, I can tell you that it's definitely not any of these three, because they are significantly less than 10 to the power of 3. I would also say that it's most likely not that bottom one. Is this thing going to open or what? Okay, weird. Alright, I might have to try and do it with the, I think this one has, if I change it to a scientific calculator, it has, yeah. Okay, anyway, so it's probably hard to see because I've got this one over the top. What I'm trying to do, I'll just make this full screen, is I want to find out the log. Okay, it doesn't work that way. I guess I have to put in my number first. 3.56 log. It's log of 3.56. Okay, so that's not really how it works either. Yeah, just want to clear everything. No. I mean, there's probably an easier way to do it, right? If I know the logarithm of 3.56, it's just 10 to the power of 3.56, which is 3060.73. Let's bring that back up. It's the one that we suspected. Okay, order of magnitude of 479 would be 10 to the power of 2. a number whose logarithm is 1.89. Okay, we're going to do that again. 10 to the power of 1.89. I know that I'm not really showing it, but it's not particularly exciting. 10 to the power of 1.89. I can probably just budge this over a smidge, and you can see the calculator fine there. There you go. All right. So I did 10 to the power of 1.89, and I got 77.62, which is that one there. The value of 10 to the power of 4.1. 10 to the power of 4.1. 12,589. 12,589, that's this one here. Alright. Correct two decimal places, the number whose logarithm is 3.456. It'd be one of these ones, at the bottom. $2,857. 57.59, so it's that one. Okay. What's the order of magnitude of the number of spectators if they're given? So it's 48457. I'm guessing this is supposed to be over 100,000, but who knows? 51,798. Yeah, it's just over 100,000. Okay. So the order of magnitude would be 10 to the power of what am I doing? 1.00255. 1, 2, 3, 4, 5 is my order of magnitude there. Alright, for the given values, use the log x transformation to check if this transformation gives a linear graph. Sure. So we're going to do log 10 of x. This should be log 10 should give me 1. I mean, I could just do these myself. That's 10 squared, 10, yeah, anyway. Log of 500, what's that? 2.70, correct to one decimal place, 2.7. And 1,000 would be 3. Now I get to graph them, lucky me. Log x is 1 and y is 5, so it's about there. Log x is 2 and y is 8. Log x is 2.7 and y is 10.1. So it's about there. And then we've got 3 and 11. I'm going to stuff this one up. 2.7. It's supposed to be more like there. It's probably a little bit straighter. So I'd say that's pretty linear. Just forget my one that I've drawn out there. Good. Alright, now we're doing the log of the lifespan for this graph here. So log, that would be 0. Just because 10 to the power of, or anything to the power of 0 is 1. Log of 28 days. we have a 1 decimal place. 1.4 log of 365 is 2.6. Log of 3650, 3.6. Horse 10950. Give you 4. Through the bell just went. 31390 will give me 4.5. And the last one, 69350 log is 4.8. Okay, so I've done that. Plot them. So I think, yeah, I'll plot them very quickly. So 0 and lifespan. I see 0 and 1260. It's like right up here. Oh, hang on. That's 1150, 12. Yeah, more like that. Anyway, 1.4 and 250. On the heartbeat per minute as against the logarithm of their lifespan. Yeah, okay. 2.6 and 600. 3.6 and 205. 4. Am I supposed to be doing the log? Heartbeat per minute against the log of their lifespan. Okay, yeah, this is apparently what I'm supposed to be doing. 4 and 40. It's very low. 4.5 and 30. 4.8 and 6. My God. Alright, whatever. I may have stuffed that one up, I don't know. Yeah, right on. I'm not sure if it was supposed to be the log of that, maybe. I don't know, maybe not. Anyway, what am I doing? Using logarithm values in part A, how much longer does a tortoise live for than a mouse? Okay, so tortoise is 10 to the power, so it's 4.8, 10 to the power of 4.8, minus a mouse is 2.6, meaning that it is 2.2 magnitude difference. So 10 to the power of 2.2 is 158. Yeah, so it's 158 times longer. Alright. I'll double check this one because I'm a bit confused by it, but yeah, the rest of it I was pretty happy with. So we'll leave that there. Hopefully you found that helpful. Thanks guys. Bye.